Hi. So these are the questions from DSC 2020. Okay. So let's solve them. So let this is the symbol for greatest integer function, and it means that you have that whatever the number you have in it, whatever the x is, it has to be the greatest integer that is less than or equal to x. Okay. So whatever number you put in, let's say 1.6. The resulting number has to be the greatest integer that is less than or equal to x. So what is the greatest integer that is less than or equal to this x? Okay, so that is 1, right? 1 is the greatest integer that is less than or equal to 1.6. So what are all the integers that are less than or equal to 1.6? Well, those are -1, you have 0, 1, -2. So all these integers are less than 1.6. And what is the greatest out of them? Well, the greatest of them is 1. Okay, so that's how this works. Okay, the function f, where domain is R and codomain is also R, defined by the function fx equal to x minus greatest integer less than or equal to x. Is it left continuous or right continuous, or left discontinuous and right discontinuous? Okay, or discontinuous everywhere? We have to check that. Okay, and similarly, in the next question we have smallest integer that is greater than or equal to x, and again you have to check left right discontinuity. Okay, so let's begin with this. So what's left and right discontinuity? So we know that in general is our function is continuous at point C if limit x tends to C minus fx is equal to limit x tends to C plus fx is equal to the value of the function at C, right? This is the definition of continuity. When you approach this function from the left or from the right, you reach at the same value as f of C. Okay. So what is left continuous? So when you approach this function from the left, okay, when you approach this function from the left and it approaches the same value as f of C, but it is not equal to when you approach this function from the right. Okay. So this is a left continuous function. How? When you approach this from the left, okay, it approaches the same value as f of C, okay, and then if you approach it from the right, you are somewhere here, okay, which is not equal to f of C, okay. So this is left continuous. Similarly, this is an example of right continuous function. So when you approach this function from the right, okay, it reaches the same value, it approaches the same value as f of C, which is here, okay. And if you approach this function from the left, you are somewhere here, okay, which is not equal to f of C. So this is right continuous, okay. So now that we know the definition of left and right discontinuous, let's get back to the question. So I have to check whether x minus greatest integer function of x, is it left continuous, right continuous, or both? So I have to ultimately check this. Okay. So let's first begin with the graph of greater integer function, and then let's move to this. What we need to check. Okay. So if this is my Cartesian plane, then we just saw that the what is the greatest integer less than or equal to 1.6? Well, that's 1, right? What is the greatest integer less than or equal to 1.5? Well, that is also equal to 1. What is the greatest integer less than or equal to 1? Well, that's already 1. Okay. What about greater integer less than or equal to 1.9? Again 1. And what about 2? Well, it has to be 2. Okay. So uh, for 1, it is 1. For 1.5, it is 1. For 1.9, it is 1. And for 2, it is 2. Okay, it moves there. So the graph looks like this, and I can use this pattern. Okay, so for between any number between 2 and 3, it will be like this. So for all the number between 2 and 3, it will be 2, and for exactly for 3, it will move to 3. Okay, for all the number between 2 and 3, it takes value 2, because what is the greater integer less than or equal to 2.5? Well, that's 2. Okay, so that's how the graph of this function looks. Okay, so what will be x minus greatest integer function of x? Okay, so let's quickly check that. So let me check at 1.6. So at 1.6, this it takes value 1 and I will get 0.6. What about 1.5? At 1.5, it is 0.6, and at 1.5, it will be 1.5 minus 1, which is equal to 0.5. What about 1.9? It will be 1.9 minus 1, which is equal to 0.9. Okay, so now let's check the graphs. So for 1.5, exactly in between, it is equal to 0.5. For 1.6, it is equal to 0.6. For 1.9, it is equal to 1.9. It is equal to 0.9. Okay, and for similarly for 1.4, it will be 0.4. So notice that you get a 45-degree line. Okay, and at exactly at 1, it will be 0, which means that for the integer value, it will take value 0. Okay, because for any integer, this graded integer function gives you the same value. Oh, right. So this x minus greater integer function of x is equal to 0 if x belongs to the set of integers and it is the fractional part of the uh, x if x is not an integer. Okay, which basically means जैसे 1.9 है यहाँ पर इसका जो फ्रैक्शनल पार्ट है वो 0.9, 1.5 का 0.5 है, 1.6 का 0.6 का, 1.4 का 0.4 होगा. ओके, सो यू विल गेट अ 45-degree लाइन हियर लाइक दिस, एंड एग्जैक्टली एट 2 वापस 0 हो जाएगा, because you will get 2 minus 2, which is 0. Okay, similarly when you start at 2, 2.1 के लिए आ जाएगा 0.1, 2.2 के लिए आ जाएगा 0.2, 0.3, 0.4, 0.5, और जैसे ही ये 3 पर आएगा, it will get back to 0. Okay, so that's the pattern here. So this function looks like this. You can check it for all other values as well. It will look like this. Okay, now I'm just using the pattern. All right, so now, is this function left continuous or right continuous or discontinuous? What is it? So let me first check at the integers. Okay, because at all other values there is no issue. I can draw the graph without lifting the pen, right? See this. At non-integer values, I can simply draw the graph and without picking up the pen. So it is continuous there. What about the integer values? So notice that when you approach this function from the left, okay, when you approach this function from the left, you reach somewhere here, okay, and at exactly at 1, you are at 0. And when you approach this function from the right, you approach 0 only. Okay, so जो limit x tends to, suppose मैं for example 1 की बात करूं, तो 1 plus जो है of fx, where fx is this, it is same as f of 1. Okay, but it is not equal to limit x tends to 1 minus of fx, right? So लेफ्ट से अप्रोच करते हुए आप डिफरेंट वैल्यू पर पहुंच रहे हो, बट व्हेन यू अप्रोच फ्रॉम राइट यू रीच एग्जैक्टली एट f of c. Okay, in our definition, so that means this function is right continuous. Okay, this function is right continuous because when you are approaching from the right, it is approaching the same value as f of c. Okay, so that means the answer is b. It is right. It is, sorry, so डिसकॉन्टिन्यूस की बात कर रहा है, ये राइट कॉन्टिन्यूस है, दैट मीन्स ये लेफ्ट डिसकॉन्टिन्यूस है, सो आंसर इज ए. ओके, this function is right continuous, that means it is left discontinuous. All right. And it is not discontinuous everywhere because non-integer values के लिए ये continuous है. It is not left and right discontinuous because it is right continuous. All right. So answer is A. Moving on to second question of this series. Okay. Let this symbol be the smallest integer that is greater than or equal to x. Okay, so again, if I take 1.6, what is the smallest integer greater than or equal to x? So what are all the integers greater than or equal to 1.6? Well, those are 2, 3, 4, and so on. And what is the smallest of them? Well, that's 2. So it will give you 2. Okay. What about 1.4? Again, all the integers greater than or equal to 1.4 are these, and the smallest of them is 2. What about 2 itself? Well, it gives you 2 back because it includes equal as well, greater than or equal to x. So that means again you have this, all these integers which are greater than or equal to 2, and the smallest of them is 2. What about 1? Well, that is equal to 1. Okay, so that's how this function works. Okay, so and you have to check that what is the smallest integer function minus x. Is it left continuous, right continuous? What is it? So now we are dealing with smallest integer function. Smallest integer. Okay? So let's check the graph. Okay. So again, let's do it for the numbers between 1 and 2, and then we can move on to our function, which is this. All right. So let's begin with this, with smallest integer function. All right. So 1 पर ये value क्या लेगा? 1 पर it will take value 1. 2 पर it takes value 2. Okay. And what about 1.6? It takes value 2. Okay. What about 1.9? It takes value 2. और ये सब हम देख चुके हैं, right? And so it will be like this. Okay. For all the numbers between 1 and 2, the smallest integer greater than or equal to x are 2. Okay. For a number like 1.5, all the integers greater than or equal to 1.5 are 2, 3, 4, and so on. What is the smallest of them? Well, that's 2. So on. So we get 2 here. Okay. So now we can repeat this pattern. Okay. 0 पर 0 होगा. So it looks like this. Okay. 2 पर 2 है, and then for all the numbers between 2 and 3, it goes to 3. So this is how the smallest integer function looks. Now let's move to our function, which is this. Okay. So again, let me check. Let's say what about 1.5? So 1.5 का smallest integer function and minus 1.5. So it will take value 2 minus 1.5, which is equal to 0.5. Okay. What about 1.4? So it will be 2 minus 1.4, which is equal to 0.6. All right. What about 1.6? So it will be 2 minus 1.6, which is equal to 0.4. Okay. So basically, I'm trying to get an idea that how will the graph look. So graph will look like this. I have taken the numbers between 1 and 2. Exactly at 1, it will take value 0, right? It will give me 1 back. Okay. So 1 minus 1 will be 0. 2 minus 2 will be 0. So let me simply include that here. So 1 minus 1 is 0. 2 minus 2 is 0. Okay. And notice that this function, it takes value 0 if x belongs to integer, and when it is not an integer, नोटिस दैट 1.6 के लिए आपको 0.54 मिल रहा है. ओके, इसका फ्रैक्शनल पार्ट क्या है? इसका फ्रैक्शनल पार्ट है 0.6, बट आपको मिल रहा है 0.4. ओके, विच इज एक्चुअली 1 माइनस 0.6. ओके, सिमिलरली जब आप चेक कर रहे हो 1.4, यू आर गेटिंग 0.6, विच मीन्स इसका जो फ्रैक्शनल पार्ट है जो कि 0.4 है, आपको मिल रहा है 1 माइनस 0.4, विच इज 0.6. सो बेसिकली ये आ गया 1 minus fractional part of x. Okay, this is 1 minus fractional part of x. Okay, so it will look like, so 0.5, 1.5 के लिए will get 0.5, right? And 1.6 के लिए आपको मिल रहा है 0.4, which is below that. 1.4 के लिए आपको मिल रहा है 0.6, which is above that. Okay, and 1 के लिए it's 0. Okay, so it will look like this. आपको पैटर्न नजर आ रहा होगा. It will look like this. Okay, similarly between 2 and 3, graph will look like this. For 2 it will be 0. Okay, and it will look like this. Okay, so you can repeat this pattern and you will get this. Okay, so this will look like this. You can check it for all other numbers as well. Okay, so what is it? Is it right continuous, left continuous? What is it? Let me check for 2. So when I approach this function from the right, okay, you reach the same value as when you approach this function from the right, you are reaching somewhere here. Okay, and when you approach this function from the left, you are reaching the same value as f of 2, right? So limit x tends to 2 minus fx is same as limit same as f of 2. Okay, but it is not equal to limit x tends to 2 plus fx, right? जब आप इसे राइट से अप्रोच कर रहे हो, यू आर रीचिंग समवेयर हियर. ओके, एंड व्हेन यू अप्रोच फ्रॉम लेफ्ट, यू आर रीचिंग टुवर्ड्स this zero value which is at 2. Okay, so which means it is left continuous, which implies that it is right discontinuous. Okay, so this function is right discontinuous. So answer is B, right discontinuous. Now look at this question here. Okay, note it down for yourself. You have to now check whether the this smallest where this is greater integer function and this is smallest integer function. Okay, let me write SIF for this and GIF for the other one. All right, so now you have to check whether the difference of smallest integer function and greater integer function, is it left discontinuous, right discontinuous, both, or discontinuous everywhere. Okay, just check it and let me know your answer in the comment box. Okay, you can take screenshot quickly. All right, do let me know in the comment box.